You've already learned about several different types of word problems. There's a separate module on each of these types. If you feel that you have to review, just pick what you need and take a look. By now, you should also have a more or less definite way of approaching a word problem, so you won't just fumble around and get lost. Your method might look something like this. But different types of word problems require slightly different approaches. Here's the kind of problem we'll examine in this module. You're mixing 2 pints of orange juice at 50% with 3 pints at 60%. How strong, what percent, is the whole mixture? The key idea is this. If you have a total quantity of some substance and you know its percentage strength, then multiplying the quantity times the strength gives the actual amount of that substance. Watch. In our example, we had orange juice with a strength of 50%. The 50% tells us that we have a mixture that's half orange juice and half something else, in this case, water, we hope. So how much actual orange juice is in there? What's the quantity? Here's where we multiply, changing the 50% to a decimal, 0.5. And we get 1 pint of orange juice. The other pint is water. Sounds rather awful. That one basic idea is what makes mixture problems work. The total quantity times the strength, in percentage, gives the actual amount. Try it out now on the other part of our problem and find the actual quantity of orange juice. I remember to change the 60% to 0.6 before I multiply. And that gives me an answer of 1.8 pints of orange juice. But by now I've completely forgotten the original question, so I have to take another look. The question asks us to focus on the final mixture and find out its strength. How do we calculate that? For this problem, we're going to take the actual amount of orange juice and divide it by the total quantity of the mixture. Do we have that information yet? Well, nearly. Here's a table showing what we've calculated so far. As you can see, the whole bottom line is what we need to find. 3 unknowns. So, how do we find them? So far, we've done a multiplication along a row of our table. Twice, in fact. But there's another relationship hidden in the table. In the total amount column, we had 2 pints of the first juice and 3 pints of the second. Obviously, then, we have 5 pints of the total mixture. So we can add down the column of total quantities. We can do the same thing with actual amounts of orange juice. But be really careful. It doesn't work for strength. A mixture of 50% and 60% is not 110%. That's just silly and impossible as well. So what do we do now? Let's go back to our table. By adding down the first and third columns, we can fill in the 5 and the 2.8 respectively. And we'll make the strength in the middle column an x, because it's still unknown. That's what we're trying to find. But now, this bottom row of our table has the same multiplication property as our other two rows. Total times strength equals the actual quantity. And that gives us an equation. 5 times x equals 2.8. And once we have an equation, of course, it's all over but the shouting. The strength of the final mixture is 0.56, commonly written as 56%. Now you'll want to watch this technique very closely one more time. You can multiply along any row. You can add the total and actual amount columns. But you cannot add the strength column, the percentages. Another way of looking at the problem we just saw. After you're comfortable with how the tables work, you may find you can look at a picture like this and write down the equation very quickly, doing the multiplication parts as you go along. Now let's find out if that helped by trying another one. You're getting ready to go backpacking, and you have a problem with getting exactly the right amount of chocolate chips in your trail mix. A problem of considerable importance, naturally. Fortunately, it sounds a lot like the orange juice problem. But this time the total quantity describes trail mix, and we're interested in the actual amounts of chocolate. The first thing to do is set up a table just as we did before and fill in the pieces of information we already have. The percentage of chocolate chips in each of the two mixtures and the 10 pounds of 50% chocolate chips for the final mix. We're looking for two things here. How much of A and how much of B. So let's use X for the amount of mixture A and 10 minus X for the amount of B, since the total of the two has to be 10 pounds. Remember, we can add that first column, and the total has to come out right. Now, what else can we do here? Sure, we can multiply total times strength along each row, just as we did before. How much actual chocolate in mixture A? X times 40%, or X times 0.4. How much in B? Multiply it across. And the same for the final mix in the bottom row. Now the table is completely filled in, and the answer is hiding there somewhere. The question, where will we find our equation? The answer, we find it in the third column. It has to add up because the chocolate in A and the chocolate in B have to equal the total chocolate. And as soon as we do the addition, we find that we have an equation. We rearrange the terms a little, and we're ready to solve. First, for convenience, we use the distributive law and multiply by 100 to get rid of the decimals. And from there on, it's easy sailing. And we find out in no time at all that X is 6 pounds of mixture A. Mixture B was 10 minus X, so 10 minus 6 gives us 4 pounds of mixture B. Stop now and think for a moment about how each of these two problems used this table. In every case like these, we fill in what we know with numbers and variables. Then we use the multiplication and addition rules, and that gives us the equation which solves the whole thing. Think about it. Then use what you know to attack this one last problem. Don't worry, it's the same kind of problem and all the same rules apply. Here's the way you want to set up your table. You'll need an extra row because first we're draining some and then we're adding back. Fill in what you know and then work out the rest. First, I fill in all the information I was given in the problem itself. That step is crucial. Then I choose my variable, x, and add it to the table, where it stands for what we're trying to find. The two x's are the same quantity because if we drain x quantity, we also have to add back the same amount to keep the radiator full. Next, I do the multiplication step along each row, total times strength. And then I take a look at that last column. The starting quantity minus what we drain plus what we add has to equal the ending quantity. So that's my equation. It describes the final result of draining out some water and antifreeze and then adding the same quantity of a new mixture of antifreeze and water. So, working out the equation solves the problem by all the same steps as before. I multiply to get rid of the decimals, collect the terms as usual, and come up with my answer. X equals 4 4/5. That is, I should drain 4 4/5 pints of the 55% mixture and replace it with the same amount of an 80% mixture. Result, I have a 70% solution of antifreeze in my radiator. I'll grant you that that one was a little more complicated, but it used all the same steps we saw before. Stick with those steps as you do more examples from your textbook, and you won't get lost in the process. Good luck!